We all know that recharge card sellers and all other vendors that we get recharge cards or airtime from all depend on network providers like MTN, Airtel, and GLO for these airtime. But have you ever wondered where or how MTN gets the recharge cards they sell to these vendors? Have you ever also paused to ask yourself, how does airtime translate to phone call? Like, how are you able to reach out to someone by just dialing their phone numbers and the next thing, boom, you start talking with them? How does this whole thing work? Before we dive into how recharge cards are produced, let's try to have a clear understanding of how network providers operate. Network providers like MTN, Airtel, GLO, and 9mobile are called mobile network operators. They own and operate the entire infrastructures needed to provide our mobile services like calls, text, and internet connection to millions of users. In Nigeria, they operate by partnering with government agencies such as the Nigerian Communications Commission. They acquire rights to use our specific radio frequencies, for instance 900 MHz. These frequencies are used to transmit voice and data wirelessly between your phone and their cell towers. Now, to ensure seamless communication, mobile network operators have built and maintained several critical systems. They build and maintain cell towers, which are the antennas placed on rooftops or poles that transmit and receive radio signals from mobile devices. They created large central systems that manage calls, texts, internet, billing, and user data. They maintain fiber optic cables, which helps in connecting towers and call systems across the country with speed. When you sign up, they assign you a phone number and a SIM card. The SIM card links your phone to their network and authenticates you. They also track your calls, SMS, and data usage. They build switching centers which route calls and messages between users, especially across different networks. They have also built our data centers for storing subscriber info, billing systems, and network management softwares. They also partnered with other networks both locally and internationally to allow cross-network calls. Now, let's quickly understand how a phone call actually works. When you dial a phone number, let's say you are trying to call your friend. How does the call get to him? Let's say you are using MTN. When you dial a GLO number, your phone will convert the number into a signal and search for the nearest cell tower that belongs to MTN. If your phone is able to identify any MTN cell tower that is close to you, your phone connects with the cell tower through radio waves, which is usually a wireless signal. Now, the MTN cell tower will then immediately route your call request to MTN's call network. MTN's core network in this sense is not a single machine. It is a distributed system located in their data centers, and it is connected to all their cell towers across the country. MTN's core network is in charge of handling call routing, authentication, billing, SMS, and data services. Now, as soon as the cell tower forwards your call to MTN's core network, the network will then run a series of checks internally. These checks include: is your SIM active? Do you have enough airtime? Is the number you are calling valid? If these checks are passed, the call signal is then routed to a mobile switching center, which will in turn check which service provider owns the number you are trying to call. It will check to determine whether the call is an MTN to MTN or an MTN to GLO call. Now, if it is the same network, like MTN to MTN, the mobile switching center will immediately connect you to the person you are calling directly via MTN cell tower. But if it is a different network, the mobile switching center will route the call through an interconnection exchange, which is like a public switch telephone network, which is more like a bridge between networks. Alright? So it is the recipient network that will first receive the call. Now, the recipient network will immediately check the home location register to determine which cell tower or mobile switching center is currently serving the user. If the phone is available, like the user's phone is available, the cell tower will send a signal to it, and that is when the phone will start to ring. But if the number is busy or unreachable, you will get the usual message from your service provider that the recipient is busy or not reachable. Now, if they answer the call, a two-way communication channel will be established immediately. Your voice will then be converted into a digital data, alright, sent over the network and reconverted into sound on their phone. That is how you are able to speak, and they hear your voice and they speak and you hear them back. The connection is closed when either of you hang up. The system immediately calculates call duration and deducts airtime from your available balance. Now, there is a formal agreement between network providers to allow calls and SMS between them. Calls involving different networks require some connection fees on the caller's part. For example, MTN to GLO call may cost a little bit, although this cost is usually already factored into airtime cost. Now, let's look at how network providers manage call billings. As soon as you initiate a call with someone, the online charging system, which is an integral part of the intelligent network, tracks usage in real time and deducts airtime accordingly. Every second, it deducts a predefined rate from your balance. This is possible through the assistance of the customized applications for mobile enhanced logic protocol. Alright, so for example, if you have 200 naira airtime and you are on a call with someone, let's say the call is being charged as 0.15 naira per seconds. Now, if the call ends after 1 minute, 30 naira will be deducted from your account and you will be left with 170 naira. Now, the system normally deducts airtime in small increment per second or per pause. If the balance is insufficient at the next deduction point, the call is automatically terminated. Telecoms often use prepaid billing platforms like Ericsson Charging System or OYCBS for real-time balance updates. Network providers have also built a solid tariff engine that dynamically determines call rates. For instance, if the call is an international call or if there is a promo, the system automatically and dynamically adjusts the call rate depending on the situation. Now, having understand how phone calls are connected, another important question we need to address is where do network providers get airtime from? And like I mentioned earlier on, we all know that vendors and distributors of recharge card all depends on network providers for these recharge cards. Now the question is, where does network providers get airtime from? An airtime is a digital permission granted by networks to users to access their infrastructure such as calls, SMS and data. When you buy airtime, you are directly preparing for network access like buying a ticket for service usage. Alright? Now, airtime is generated by network providers. They don't buy it from anywhere. Airtime functions similar to a prepaid voucher for network systems. Telecom operators rely heavily on several back-end billing and provisioning systems to manage airtime. One of those systems is the Voucher Management System, which is directly in charge of recharge card PIN generation. And this is where we are going to be focusing on. The Voucher Management System is charged with the responsibility for generating unique PINs for scratch cards and e-recharge. It is linked to the billing system to ensure that payments are made before accounts are credited. When a telecom company wants to release batches of 100 naira, 200 or 500 naira airtime vouchers, the voucher management system is in charge of generating them. A batch of unique pins is created using cryptographic algorithms, for example, AES-256 encryption. These pins are not just random numbers, alright? So they follow a structured cryptographic process. Some digits may encode internal information such as issuer or denomination using proprietary algorithms. For instance, a typical recharge pin can be in this format. The first 4 digits can represent the issuer ID, which identifies the telecom operator. 4762 represents MTN in this scenario. Alright, now the second 4 digits can represent the encoded amount. For example, 200 might be represented by 4687. The third 4 digits can represent a randomly generated unique serial number. The number will be hashed for security reasons. Then finally, the fourth 4 digits can represent a checksum digit, which will ensure that the airtime is not tampered with. Note that this might not be the correct pattern that MTN is using to generate their recharge card, but I'm just giving you a scenario for educational purpose. Alright, now each pin is stored in a database as a hash, not plain text, in order to prevent database leaks. As the pins are generated, fixed amount are automatically assigned to them. Alright, and expiration data is also specified for the pin in the database. The status of the pin is set to false by default, indicating that the recharge card is still valid and not yet used. Network providers use databases such as Oracle DB, MySQL or NoSQL databases such as MongoDB. The pins are then printed on scratch card or stored for e-recharge. Note that telecom companies also use a technique known as geolocking to ensure that a pin generated in Nigeria cannot be used in Ghana. The home location register and the international mobile subscriber identity are in charge of enforcing geolocation. Now here's what happens in the backend when you load airtime via scratch card or USSD. If a user dials this code with the airtime digits, an API request is sent to the telecom system server. Alright, so the system extracts the recharge card pin and search for it in their database. If the pin is not found, it means that the pin is invalid. But if the pin is found and is valid, the system will further check if the pin is like a 16-digit character and has a valid format. And they also check if the pin exists in the voucher pool. Alright, and then they also try to confirm the status of the pin if it is not yet used. The next thing is that the system will check if the pin is not blacklisted. Alright, and then it will also check the expiry date. Now, if the pin passes these checks, the intelligent network system will then proceed to verify the amount associated with a particular pin in the database. The system will start by placing a temporary lock on the pin during validation to prevent race condition or double redemption. Then it will update the recharge card status to use and then update the user's balance in the home location register based on the amount specified for the pin in the database. The transaction is immediately logged with timestamp and other details. Note that the entire transaction process is 100% atomic, consistent, isolated, durable, and does not allow for partial success. Alright, Now, telecom companies use different technologies for managing various aspects of their operations. For instance, they use Java, C++, and SQL in their billing system. Alright? They use Python, Java, and C# in their voucher management system. They also use Golang, Java Spring Boot, Node.js, and PHP to manage their USSD and APIs. They also make use of Oracle DB, MySQL, and Postgres database. Alright? They use Docker and Kubernetes for microservices. They use C, Python, and Java for managing encryptions and PIN security. They use Diameter protocol for real-time charging. Finally, they use SS7 and Citran for real-time call routing. Now that you understand how network providers like MTN generate airtime internally, you might be wondering, why is airtime not cheaper or even free? Okay, now think of airtime as a bus ticket or a railway ticket. Alright, so the ticket itself costs almost nothing to create. But the bus and the rail, which represent the telecom infrastructure in this scenario, require billions of dollars to build and maintain. In summary, airtime is not just a digital token. In fact, the value you pay for it is your own share of maintaining a nationwide communication empire. Follow for more.